So here is your introduction to complex numbers. And we've dealt with rational numbers, which are just fractions. And we've dealt with, what else have we dealt with? Irrational numbers. And we've dealt with some integers and whole numbers, but we are going to add a whole new category of numbers called complex numbers, and it all starts with the letter I. And I don't mean that every number starts with the letter I as its name. What I mean is we need to understand this concept of the letter I. And the letter I is going to be defined as shorthand for the square root of negative 1. And it should go if I is equal to the square root of negative 1, then I squared must equal, right, whatever we're taking the square root of, I squared must equal negative 1. Now you're not going to find this on most calculators because if you ever wanted to take the square root of a negative number on a calculator, your calculator would not be able to find this number I. So this is just the definition, and we're going to use this definition and this fact quite a few times. But where does this come from? Why do we do this? It comes from this idea. If we had an equation, so let's answer the question, whence I. If we had an equation, we were asked to solve for x for this x. Remember, solving is like there's a mystery, and there's some mysterious number x. Let's say that when we square it and we add 1, or let's say we add 4, we get to 0. So is this possible? Well, let's use our algebra skills, and let's isolate our variable. So if we subtract 4 from both sides, we get the idea that it must be that x squared is equal to negative 4. Well, right away, without looking back over here, say no. There's no number we can square and get a negative, so you would write over here maybe something like no solution, and that's sort of where you would might have stopped before. But now that we have this information up here and here, we are going to have possibly a solution. So let me get rid of that. Boom. And now let's continue to try to isolate x here. Let's take the square root of both sides. So square root of both sides. There's a lot of different ways we're going to be simplifying square roots. But if we take the square root of x squared, we are left with x. And on the other side, we are left with x is equal to, now whenever we take the square root of something, there's the positive square root and there's the negative square root. So I'm just going to write positive and negative out there, and then I'm going to simplify the square root of negative 4. So this is equal to the square root of negative 1 times 4. Right? All I did was write write negative 4 as the square root of negative 1 times 4 inside the square root. PEMDAS. Okay, so this would imply that x is equal to plus or minus the square root of negative 1 times the square root of 4. Okay, the square root of a product is the product of the square roots. And that's something hopefully you remember from Algebra 1. Okay, so what's next? Well, let's use our definition. We have the square root of negative 1 right there. We just said the square root of negative 1 is going to be I. So this is equal to plus or minus I, and the square root of 4 is the number 2. And typically we would write this, well, convention is to keep the constants first before the I. So this is plus or minus 2I. And if we took this, so this is our solution. I told us to solve this mystery. If we were to put in positive 2i back into our original, remember anytime we check we would want to go back to our original, which is right there. We would put plus positive 2i in there and use our definition that I squared is equal. Let's do that. Here is our check. So let's try x equals positive 2i. Let's do it. So 2i squared plus 4, is that equal to 0? Well, 2i squared is 4i squared plus 4, is that equal to 0? Well, we just said that I squared is equal to -1, so that's -4 plus 4 equals 0. Check. X equals -2i. Is that, let's check that, -2i squared plus 4 equals 0. Is that true? Well, this is a negative times a negative squared is going to give us a positive 4i squared plus 4. Is that equal to 0? Of course it is. We just did that a second ago. That's -4 plus 4 equals 0. Check. So there we have the reason why we have the imaginary root. Okay, or I'm sorry, the imaginary number I defined as the square root of -1. So we need to do some examples. If we said, for example, so here's again using this information. Here's an example. Let's simplify square root of -9. Oh, it looks pretty simple already, right? Well, this is just square root of -1 times the square root of 9. And that is, we said the square root of -1 is I, and the square root of 9 is 3, so this is 3i. Let's do another example. Let's simplify 2i times 3i. Well, we could just rewrite this. Multiplication is still commutative, which means order doesn't matter. This is 2 times 3 times I, and that's 2 times 3 is 6. I times I is I squared, so this is equal to -6. That's a good simplification, right? No one will doubt that. This compared to this guy is definitely simpler, right? Okay. Also, let me just say quickly, simplifying and solving are two different things. Simplifying or evaluating, right? When you simplify something or evaluate something, you do not put plus or minus. When you solve something, you're coming up with all of the x's, right? So x squared is equal to -1. You're coming up with all the x's that can possibly satisfy this. And x is equal to plus or minus I. These are all the x's that can satisfy this. It's very different. So this is the difference between solve and simplify. Okay, let me do another video.